Imagine two teams in different cities, each keeping a list called customer. One team adds anyone who ever visited the website. The other team adds only people who completed a purchase. Both tables are customer, same name, different expectations. When someone tries to join these tables, confusion follows. Duplicated rows, wrong cohorts, and frustrated analysts asking, which customer do you mean? That everyday mismatch points to the idea I want to talk about: semantic boundaries. Boundaries are where meaning is decided, where we say, inside this box, these rules apply, outside it, different rules apply. They're not physical fences, they're agreements about definition, ownership, life cycle, and responsibility. Let's unpack that. A semantic boundary divides two or more systems, datasets, or teams, and marks a change in how data should be understood. On one side of the boundary, a field means one thing. On the other side, it might mean something else. Boundaries create safe places to design semantics locally so that teams can move fast. But they also create seams you must stitch carefully when data crosses from one side to the other. Why do boundaries matter? Because data travels. It's created in one place, transformed in another, and used somewhere else. Every time data crosses a boundary, assumptions travel with it, and assumptions are fragile. If you don't make the boundary explicit, you end up translating meaning by accident. Let's look at common kinds of semantic boundaries. First, domain boundaries. These divide different business areas. Marketing defines a lead differently than sales. Finance defines revenue recognition differently than analytics. Domain boundaries capture different perspectives and responsibilities. Second, system boundaries. These are API contracts, databases, or message queues. A timestamp emitted by a mobile SDK might be local device time. A server's timestamp is UTC. The SDK and the server form a boundary where semantics about time differ. Third, granularity boundaries. Data can be aggregated differently. Hourly logs versus daily summaries. The aggregation level changes what the numbers mean. A spike visible in raw logs can disappear in daily aggregates. The boundary, raw versus aggregated, changes the semantic of the metric. Fourth, ownership and lifecycle boundaries. Who owns the data? Who is responsible for fixing it when it breaks? Does the source system retain authoritative history, or does the warehouse become the canonical record? Ownership decisions draw boundaries around who decides what truth is. Fifth, regulatory and privacy boundaries. Some data can't cross into certain systems because of legal or privacy constraints. Those boundaries aren't optional. They encode external semantics, what we're allowed to represent and where. Now, working with boundaries well is mostly about making decisions explicit and building predictable translation between sides. Here are practical, human-centered patterns that help. 1. Name your boundaries. Call the dataset or API what it actually is. If a table contains visitors, don't call it customer. Be precise in the name and the documentation. A clear name is the first line of defense against sloppy interpretation. 2. Publish a contract at the boundary. A contract states the fields, units, data types, and semantic expectations, plus who owns them. Think of it like a short README that travels with the data. Contracts reduce idle guessing. 3. Provide adapters, not silent rewrites. When data must change meaning as it crosses a boundary, put the transformation in a dedicated adapter or translation layer and version it. Don't change semantics in place. Translate explicitly and log it. That way you can audit what changed and why. 4. Design for asymmetric expectations. The producer doesn't need to know every consumer's needs, but the contract should be rich enough that consumers can adapt. For example, emit price together with currency and price unit. That small extra context makes the boundary survivable. 5. Choose the right canonicalization strategy. Some organizations pick a single canonical model, one representation of truth, and map everything to it. Others accept multiple canonical views and maintain mapping tables. Both approaches work. The important part is deliberate choice and solid mapping logic. 6. Version your boundaries. When semantics change, treat it like a software release. Publish a version, provide migration notes, and give consumers time to upgrade. Rolling waves of change without versioning are what turn small updates into silent data disasters. 7. Monitor boundary health. Set up checks that run at the boundary. Schema validation, unit checks, referential integrity, and distribution checks. When these tests fail early at the seam so you can fix the source rather than chasing symptoms downstream. 8. Define ownership and SLA. If the customer table causes problems, who fixes it? A named owner and a simple SLA. A promise like critical issues responded to within 1 business day make parties accountable. They prevent finger-pointing. 9. Document assumptions and exceptions. Boundaries live in the grey areas. If a producer emits a null in a field under certain conditions, document why. Capture edge case behaviors so consumers don't invent their own interpretations. A few heuristics for where to draw boundaries. Put boundaries where ownership is clear. If 2 teams share responsibility, it's harder to agree on semantics. Put boundaries where change is frequent. When one side changes often, isolate it so you don't force other teams to adapt every time. Put boundaries at legal or privacy seams. Laws and policies often dictate where data must stop. Put boundaries to manage coupling. Favor loose coupling. Well-defined interfaces and translations reduce ripple effects. Finally, treat boundaries as living artifacts. They'll change. Make change visible. When semantics shift, update the contract, bump the version, and notify consumers. When a boundary consistently causes friction, revisit it. Maybe it needs to be moved, split, or merged. Boundaries are not obstacles to collaboration. They are the places you negotiate clarity. When you draw them thoughtfully, you let teams move independently while making it safe for data to travel across the organization.